See it in general?
In the slide.
Yeah. Oh, why? Yeah. We are. That's all I see in the channel. Okay.
Can you see my screen?
Oh, so I can share.
So I know what you're talking about.
There we go. Let me.
So it's not now.
Sweet. Let's give it a few more minutes, a couple more minutes. We have the presentation by Gaston. Aside from that, okay.
Mine will take more than 15 minutes. So.
Okay. Okay. Where's our road? Huh. Right. Our roadmap is still on the wiki. Okay. Did I respond? Oh, maybe I should ping here. Okay, I want to get started. So we don't have anything aside from on the agenda aside from the health checks presentation by Gaston. This went in a while ago, right? But we haven't actually had a community presentation on it, so I think it'd be a good opportunity to. That's it. I thought it'd be a good opportunity to talk about it at the community level, and then we can talk about the website migration thing that we're going to talk about after. Okay, go ahead, Gaston.
Okay, so yeah, I will start by introducing myself. I'm Gaston. I was working a marathon for a little over a year until October last year, and since then mostly on Mesos. So I was pretty involved in the development of health checks and checks. That's why it's in parentheses. It's two different things, and I'm going to explain the difference in this talk. So yeah, the idea is to talk about what health checks are and how Mesos supports them. Then what's the difference with a plain check, and give some implementation details. Talk about the scalability because we've done some scale tests, and then there will be some of the questions.
Okay.
So first is our health checks. What is health check? What do they try to solve? The idea is that it's very easy to know if a task crashes because the container will just die, or that your executed node. But what happens if you have an application or a server that is stuck in anything low? So it never quits, but it's not doing anything useful. Or if it's only serving errors, how do you detect that? And that's where health checks come to scene. Basically, what you can do to detect that situation is to probe your task periodically, either through via HTTP or trying to do a TCP connection, or you can run a command in the same namespaces and on the same node as the task. And based on the exit status, you can decide whether the application is healthy or not. Like you could try to connect to a database or something like that. And normally, the reaction would be to kill the task if it fails some certain amount of probes or health checks. It's normally not a good idea to kill it if it only fails one check, and because it might be slow, moderately slow or something like that. It's not, yeah, normally you specify a maximum amount of failures, and if it reaches that, then you kill the task. So when you define health check, what you define are some type-dependent parameters, depending on whether it's TCP, command, or HTTP. So you normally define the port for TCP and HTTP. In case of HTTP, also path. So you will do a get or post and then you specify path. Or otherwise you specify a command that will be run on the agent. And you also define how often to run that, and you give the timeout, because if it's in a loop or something like that, it might take a long time to respond, and you, after giving timeout, don't you consider it unhealthy. You can specify a grace period. That means that until the first, so you accept failures for that grace period until the first success. Afterwards, each failure is really considered a failure to be recorded. And then the maximum consecutive failures that you want to allow. Yeah. So that's health checks now. We also introduced the concept of checks. And it might be, like the naming can be a bit confusing about the difference of a health check and check. So I want to spend some time explaining that. The problem that we want to solve is that even though you might have a task that is running, it might need some time to warm up. Like it might load something from a DB, or it might need to cache stuff, might need to transfer data from another node or something like that. But the fact that it's warming up doesn't mean it's unhealthy. It only means it's not ready yet to do something. So health check would not work because if health check fails, then Mesos or a framework would just replace it. That's what keep it and replace it. And also, Mesos health checks. So when Mesos does a health check, it doesn't report the HTTP status or the exit status back to the framework. It just sends in the task update a Boolean flag saying whether it's healthy or not. So it's not enough information to make a decision. So we introduced something new called checks. They're very similar to health checks. It also runs something on the node. Supports HTTP, TCP, and command probes. And the difference is that the executors won't interpret the result of the probes. So Mesos will not kill a task based on checks. There's also no concept of a failing check. If an HTTP connection returns 500, it will just send a task status update to the framework saying that the result was 500, and then the framework can decide what to do with that. And so the decision is no longer local at the node level. It's now something that is done by the framework. What Mesos will do, however, is deduplicate the results to make it scale. So if it's always 500, like if the result is also 500, it will only send it the first time, and then it will send another update when it changes to something different. And so say there's no concept of a failure. If a check, for example, times out, what will happen is that Mesos will send an update, an empty update, because there's no information to, like there's no return code. They will send an update say that it executed a check.
Yeah, so the framework needs to act the message. So the framework needs to act the message.
Yes, it's a sort of update.
Why is that?
Because that way it's ensured that they will receive it by the we get a semantics again at this one. some updates.
Just for reliability.
Yeah, because we duplicate. So otherwise, if you miss the first one,
Instead of using like messages.
Yeah, that's actually the process. But first of all, what happens to
Well, I think my question was, for example, doing deployment or something, and I want to see that's very good for something deployment. So yeah,
providing that message to receive city, you'll check that's on, and then this resolve that check.
but one of the things we do with the application, so we will only send, so let's say your class is healthy, we will only try to send it once. And if you're going to add that, maybe it gets lost, then you might not get any updates anymore. And yeah, and there's no way of requesting like another update or something like that.
So we always send a check status.
Yes. So that's to reduce traffic and also like, yeah. There are normal tasks such as updates, you can also get in stage JSON, so you can get most recent result, which can be used for by load balancers, for example, or you're putting it together recording.
The way they find it is by look at the code.
just get a code of the status.
Yeah,
Status result.
it's pretty hard to hear. The questions,
Oh, wait, why?
discussion. Yeah.
Why is it red?
Are you able to hear us fine now?
I think it's
I think we are muted.
Yeah. Is that better, Ian?
Yeah, it's better.
That's a bit better?
okay. So did you get the question or not? Because I can like give a summary for the set.
Well, it's okay if we continue.
Okay, yeah, so the question was why we send these checks updates into the task status update and why they have to be acknowledged by the framework. And the answer was that the executors will deduplicate the updates. So if the check status doesn't change, it will be sent only once, and we don't want that to get lost because there's no way of asking for a new status. And also, it is exposed via the state endpoints. So external tools like a load balancer or something like that can query that and decide where they want to add, like send traffic to the task. And that's actually one of the main motivations for having checks, being able to, during a deployment, decide whether we want to continue deploying something or we want to wait for a task to be ready, and also to know whether we can start sending traffic to the task or not. The parameters are very similar to the ones for health check. We still have like for, path, or command. Also an interval because they are doing the probes are done critically, and there's a timeout. But there's no grace period, nor a maximum conservative failure setting because again, Mesos will not do any interpretation there. It's up to the framework, and then they can define that. Yeah. So grace period is only used in the case of health checks to allow failures for a certain time, and there's no concept of failures if it doesn't make any sense. So yeah, I wanted to talk about some implementation details, how in the past and now some frameworks has implemented health checks and checks. There are two different approaches that can be taken, have been taken in the past. One is to probe tasks remotely by another entity that's not part of Mesos, like a scaler, for example, and that's how Marathon implements HTTP and TCP health checks. Another approach is to have something running in the agents that locally probes the tasks. That is normally the executor, and that's what, as far as I know, Aurora does with Thermos, and what Mesos until Mesos 1.1 supported for command health checks. Now, in recent versions of Mesos, we also support doing that for command HTTP and TCP health checks. There are some issues with probing from the scheduler, which is what Marathon was doing and still supports. One of the things is that because Mesos is not involved there, the API for health checks can change from one framework to another one, and all the frameworks have to implement that functionality by themselves. So yeah, that's kind of annoying, and you can always make new bugs when we're implementing stuff. One of the main problems as well, or limitations, is that all the traffic comes from another module outside of, or another box outside of the node, and that can be a bottleneck, and it's also prone to network failures or configuration problems that can lead to false positives, like, yeah, well, negatives actually would be like, could lead to say that the task is unhealthy when it's actually okay, just because there was a network base or something like that. And as I said, we did some scale testing with Marathon and noticed that health checks are a bottleneck, and switching to the R approach fixes that, which is where what we call Mesos native health checks come into picture. As I said, again, like command health checks were supported for a long time, but there was a schedule for TCP and HTTP and HTTPS health checks. Starting with 1.10, sorry, 1.1 to 1.10, we updated the protocol buffer messages, and now it's possible to express when you launch a task that you want an HTTP or TCP health check and pass all the parameters that I explained before. We also introduced a health checking library where we implemented those 3 types of checks, and that library can be used, or it is used by all built-in executors, by Docker, default, and command executors, but it can also be used by custom executors. It's just written in C++ and using the process, so it can be used by anyone. And yeah, using that library, so because this is a library to perform health checks from the agent, so those probes now run very close to the task. They run from the same namespaces, connect to localhost, don't go through the network or anything like that. The decision whether to kill or not the task is still performed locally in the node by the executor in the node, like it was before for command checks, health checks. So that's good, and let's scale better, but there are still some limitations and fails. One of the limitations is that running probes locally on the node consumes extra resources on the agents. There's also some overhead from doing a fork and executing the probe. All kind of probes like HTTP, TCP, and command checks are treated as a new process that will enter the namespaces, and then either do a TCP connection or an HTTP connection, or just run a command defined by the user. Yeah.
Can you see that for the class?
For what, sorry?
For example, using contact.
So actually, the default executor runs the task by an agent API call called launch container. Well, when you what it does then, so the library has a special handling for that case, and it will use launch containerization to start a container. And you're still creating a new process.
Even for HTTP contact, why do you
there's actually to do that. You could improve performance by having a long-running process and stuff. But for now, it will create it will invoke a new process. Yeah, for HTTP, it equals actually core.
What does that process do? What is that process? That process will do?
It's core, and the reason why we did that is like we for example, HTTPS, it handles like with certificates and that stuff. We didn't spend time implementing all of that. We could use the core now that it is supported in Mesos, but it's up to you to find that. Yeah, and so those processes run in the same namespaces and C groups as the task. So if the task didn't give any resources available for checks, then they will fail. Or if you are running a command and the command goes crazy, and then it might consume resources for the task. So you have to be careful there. And again, as I said, the probes enter the namespace of the task, including the network namespace, so they just connect to localhost. And if your task is not bound to loopback, then it will fail. That's a limitation. You can specify an arbitrary IP address. And the executor is the one responsible for deciding whether that's going to be killed or not. So it's not possible to make like a global decision if you use type checks. That's why we introduce checks. If you use checks, then the scaler can get the check updates for different tasks and different nodes, and then use that information to make a smarter decision. Yeah. So once we implemented HTTP and HTTP health checks in Mesos, we did some scale tests, and we wanted to compare Marathon's performance with Mesos' performance. What we found out was that there's a bottleneck in Marathon. If you're using HTTP checks done from the Marathon master to the tasks, and it will work okay until you reach like 1900 tasks. Well, once you do that, it will stop reporting tasks as healthy, which has not known state. And if you keep scaling the number of tasks up, at some point Marathon will crash. And the same happens with TCP checks. TCP checks are a bit simpler from the Marathon point of view, so it can handle more tasks. But after like 2700 tasks, it will just become completely responsive after this. But at least that was the case around October last year with Marathon 1.3. Things might have changed a bit, but yeah, like there's conceptually a limit there because you're doing all the roles once again with the single machine, and there will always be an algorithm. With Mesos health checks, we realized that, or we designed them in a way such that they will scale horizontally. So if you need to run more tasks, you just start more nodes, more agents. And because the checks are run locally there, it just scales horizontally. We did some tests on AWS, and we were able to saturate. So it means start as many tasks as would fit on some M3X instances, and we were able to run about 220 tasks, and which is all that fits in that machine. And we're able to scale to an arbitrary number of nodes. Because again, like the updates are deduplicated, so you will only get the one update whenever something is healthy. There might be a corner case when you have a task that is flapping, and that will create a lot of traffic, but we didn't try that scenario. Yeah, that's basically what I had. I also wanted to thank everyone involved in this work, which was mostly Alex, who saw how then being trading, and I might be forgetting. So thanks to everyone. And yeah, if you have any questions or anything. Yes, sir.
Can I use the same house check for, let's say I'm adding like standalone. That's the same house check library.
I guess also the library is just like a couple of preprocesses. It's a couple of classes that wrap preprocess processes and do the checking, so you could use that in a command.
So potentially agent can use that library to house check a standalone.
Yes.
So agent basically gives house check library a check info and stack a check info status.
Yes. Got it. So when it creates when it creates a class,
So the library will need a check info status once you feed the check.
yeah, you specify a call like and that call like will be called with.
Check status.
Yeah.
Oh.
Actually, there are two classes provided. One is a checker and the one is a health checker. So if you want to do health checks, that
I don't want to do house check. I want to do a check, get some status, and then based on those status, it's our to
standalone.
It uses the launch nested container section called for the library.
So that's what
We
happens.
haven't done that yet.
I know, well, that's what I'm saying. You couldn't use it with vanilla container.
Well, I mean, it does two things depending on which executor you're using. Well, I mean, not that the executor uses it as a normal, but depending on whether you specify an agent URL or a PID, it will either call subprocess and then do all the ZNS stuff by itself, or if you specify an agent URL, it will do an API call to the agent and then use one session.
Okay, so it handles the same
Yeah.
library, it handles the.
Yeah, so that's the idea of the library. It does all for you, all the work for you. Yeah. And as I was saying, like, if you want some like health checking like behavior, it also keeps track of failures. Yeah, and grace period and stuff. But you can decide, you can either use a checker and then do the interpretation by yourself, or you can use a health checker class, which already some version.
Oh, so there's a house checking class that embed those decision making
Yes.
things.
But there's a checker and a health checker. You can use whatever suits your use case.
Wait, so I don't think I followed the library stuff. JP actually asked what is the health check library, and he asked to follow up with a dev list, just with a pointer. So if you can follow up with that, that would be great.
Yeah, I said, yeah, we're going to library. It's just some classes, because classes that you can use from.
It's not a
Yeah,
separate
it's
library that we package separate. It's just inside
But-
Mesos.
but-
So
But who's you? The framework writer?
Yeah, the framework writer. So if you're writing as an executor, you can use them like you can use any of the other C++ code.
do you expose to the public header?
I think not. We're using also from the VM.
It's internal. So it's internal.
Yeah, so, customer cannot use it, but it's internal library. You can expose it and
Yeah.
public, then there's a class.
Wait, so who uses it now then? We
Default
use it
executor,
internally.
non-executor.
All the things, those Docker command and default executor. And if you're writing your own, or if you have already written your own executor in C++, you can just, when you compile it, like point it to that stuff.
Only if you expose it.
Yeah, we expose it before the need.
So yeah,
So-
that's like a to
But I mean, but that means we use it with some default behavior, right? Like we have some default checks that we do for the default executor and the command executor.
So,
Like, because it's, I mean, we use the library, but it's not further customizable.
it is like the values are customizable in the task info. There's a check-in that you can set.
Oh, okay.
There's the health check behavior.
Oh, I see. What kind of things can you do that?
Like interval parameters that you saw in the slide.
Yeah, so
What type of check you want to do.
Okay, I
How
see.
frequent you want to do it. How many failures
And like what port to check.
Grace period.
yeah, and then you can specify a callback, and you will get that will be called each time there's an update.
Okay.
In the case of the checker, it will be duplicated. In the case of the health checker, you basically get like a Boolean saying where it's healthy or unhealthy.
So what type of response does the TCP health check expect?
It doesn't look for a response. It tries to connect to a port. And if it can connect, then it's just was successful. If not,
Did you that behavior or something used?
Well, just the boundaries that don't seem all that clear to me. Like what I don't actually know what the library helps me do.
The library just handles checks and health checks for our default executors in Mesos.
but you could use it if you're running your own executors. Like you don't have to then take care of trying to start a container in the same namespaces, or keep track of failures, or retry if there's an agent disconnection, or choosing what to use, not just a container, or
So I guess okay, so I guess my question is the API that I'm talking to the library with the same as like when I use once it becomes a public library or whatever, and I'm writing a custom executor and I'm talking to the library, the things that I specify are interval and port and what kind of checks I want to do and things like that, or is it more flexible than the ones that are provided in the check info protocol thing?
it's what is specified in the protobuf,
Okay.
and then you specify some information about your container that you want to. It uses the same protocols.
Okay.
You also have to pass either the P or the HTTP URL so you can connect and the next spaces. So there's some extra information. The
Okay.
parameters are the same.
Okay. Okay.
So there's a check-in flow that is on the task. And someone gets interpreted and do the check-in. And the default execution will contain the help of library. And if you make the library public, which is not there,
Mhm.
and if you have a custom executor and you want to use the such library, make public, you could also use the library to interpret this check-in flow. Instead of implementing the whole logic about how to talk to the task, how to do that stuff, the custom exec could just use this library, feed in the task check-in flow essentially, and then say give me some callbacks and then just instead of things.
Okay.
So using that, you can run something periodically in the same namespaces as your task. Could be like you can build a check-in for proto, but not using for check, like for anything else. And your executor does that and runs stuff, and then based on result decides to do or not something. You need to send it back to the framework.
So is the idea to move to using one of them, or are they both useful for different things and they're both staying, or
So
what's the vision there?
You mean checks and health checks? Or,
Yeah. Because like it seems like the only difference is really just the strictness of it and whether Mesos takes action on it or not. Right?
Yeah, it's also why it tries to
Yeah, I think at least in V2, the plan was to compose a check to be a check info. I know they're completely two different photos, no shade fields at all. At least from earlier discussion with some folks, the idea was that we would have a check composed out of check info and having information.
Yeah,
Logic and the killing logic, consider this logic be something special to have a check and have that include the check for how to run, how to run and what to do.
Yeah, right. Well, I'm less curious about the API per se. I'm more curious about like are both of those functionalities going to stay?
So the functionality, I think, might stay. What we want to do is like make it quite like a more unified API where you define what to throw, and then optional what to do, how to read that result, and what to do if it fails or not.
Okay.
Right now it's two different things.
Right.
With the new API version, we might merge that, but you would still be able to do both things. Like Mesos could still decide locally to kill or not the task, and we would also let frameworks take that decision.
And when you say Mesos, just exactly, it's not it's there's been executors that have this logic. There's been executors.
I see.
I want to interpret it. It's something
Got it. Got it. Okay. All right. Yeah.
I think in the near future, we will have the both of them.
Okay.
So the checks are right now, well, they will be used by some stateful frameworks like Cassandra and stuff like that to like orchestrate a deployment to know when you can continue deploying tasks and when to wait and stuff like that. Whereas health checks are already used to make sure that something is running and not crash.
So the question is, house checks sounds like a combination of check and a
Some emotional process.
Interpretation policy.
to decide when to turn.
Yeah, at some point we might want to change the process.
I think ideal separation of termination policy and
Yeah.
maybe the restart policy.
Yeah, we
Once you
discussed
terminate,
about
decide what to do.
some folks maybe it's just too much to do anything we want. It's complex. But we have some ideas as a doc that we can put some photos on how the photos will look. And do if you do that. Right now, they call it code duplication, which is what we're trying to first address in the code and checking is completely different codes. Like consolidate and have a abstraction that could use and coding duplicated. Basically, if it is duplicated, which more depends in
And also, it's a start or the standalone. You have a chat info, which decide how to do the chat, and then agent can decide based on the result of the chat info, to decide whether to kill the termination policies, decide whether to kill them. And even terminating, I want to have what to decide whether to restart it. Based on the restart policy.
restart policy. Yeah, that applicants are adding on task groups and stuff. So it's on the task group now. They haven't talked about containers. They have some experience about where to put it. They create a task or task group or example and what is it. For things like local sets of tasks. But we haven't talked about the standalone container that you like my particular discussion about.
As long as it's top level.
Hey guys, I think the conversation is a bit inaudible to anybody online. I'm not sure if it's just me or others as well.
It's pretty bad.
It's still bad.
Yeah, I mean I guess the conversations you guys are having within between yourself, that's pretty much inaudible to anybody online. I think.
Okay.
So maybe everybody joins online.
We'll make it. Let's have David come back. You just muted it there.
It's supposed to be green or?
I think it's on.
I think that's fine. But when you press it, it goes red, and that's muted.
Okay.
I think it was on. It's just maybe you need to talk louder.
Yeah, sorry guys, we'll try to talk a little bit.
Yeah. Any more questions? People online?
Yeah.
Go right there. Good, thanks, that's fine.
Thanks, that's all.
I guess a couple of things that I wanted to bring up was the first thing is Mesos North America CFP. So in 2 days, please submit it. In Los Angeles this year, food was low. My boys. So yeah, if you're thinking about what to submit, if you need some help, reach out to us on mailing list. And I think the contract submitted already to Mrs. Ganesha, they were taking North America, the different sets of audience. So it's totally okay if you want to. We submit them like automatically.
Do they not roll over?
What's that?
Do they not roll over?
I guess it's not official, but.
I guess it wouldn't necessarily make sense for them to roll over. Very
Yeah, it doesn't
different.
make sense.
Yeah.
They're very different places.
It's kind of assuming a lot.
You roll over, like some policy might not.
Yeah, and some
If you want
people
to
might
be
not.
so good, that's really.
Yeah, that makes sense.
Only thing that's automatically.
Yeah, that makes sense.
And maybe they will not make it.
Right.
So please do submit, especially if you are from US and from Asia, please submit. And the other one, about conference, make sure that I'm not Okay. Cool.
Oh yes, by the way, so hackathon is coming there, like any ideas for project that you guys want to work on, hackathon, let us know. Can reach out to me.
Okay.
I saw some messages.
Well, it's still pretty inaudible. It says.
Still,
Yeah.
Let's speak up. Screen.
How about now?
Yeah, so the back table we can barely hear, but the front part of the table we can hear real good.
Is it maybe just the computer?
Okay, so what Amber was saying, he was saying was that if you have any hackathon ideas, then reach out to him for
I wonder-
explanation.
I wonder if this thing is not connected properly.
Put that on YouTube.
Yeah. Yeah. Can you guys still hear me here?
Yeah, we can hear you loud and clear, but the back table.
Oh, it's because I'm gonna reconnect the system here. Hold on. I think it was on my laptop the whole time.
Yeah, I think so.
But why is the mic not?
Is it definitely connected to one of the?
It is.
For these solutions, it's only the president
This is. Okay.
Yeah, because it's different audiences.
Okay. Let me rejoin.